The flyweight pattern makes millions of objects efficient by separating shared data from data unique to each one. Picture a forest with millions of nearly identical trees. Picture a game drawing 1 million trees. Each tree object stores its own name, color, texture, and mesh, plus X and Y coordinates. But the heavy texture and mesh are identical, duplicated a million times. The memory meter climbs into the red as the same data balloons endlessly. Notice how trees fields split in two. Intrinsic state, name, color, texture, mesh, is identical across millions of trees, so we store it once. Extrinsic state, the X and Y position, is unique to each tree and stays with the caller. Only the intrinsic part is worth sharing. Here's the solution. We create TreeType, a flyweight that holds only the heavy intrinsic data, name, color, and texture. It's built once, then reused. A TreeFactory caches each tree type by name and color, returning the same instance for repeat requests. Now every tree keeps just X, Y, and one reference. Millions of trees share a single object, and memory drops back into the green. The TreeFactory keeps a cache and exposes getTreeType. It produces TreeType flyweights, which hold the shared intrinsic data and provide a draw method. Now the client side. Each tree stores its X, Y, and a TreeType reference, delegating drawing. Forest holds thousands of trees, all sharing one TreeType. Look at the before version. Every tree allocates its own texture and mesh, wasting memory on a massive scale. The flyweight version calls factory.getTreeType with a name and color, so identical types resolve to one cached instance. The draw method takes the X and Y coordinates at render time. 1,000 oak trees now share a single tree type. Separate intrinsic state into a flyweight, pass extrinsic state in per call, and reuse instances through a factory cache. The result: dramatic memory savings and cheap, lightweight objects.